In today's lecture, actually, we are going to learn a new method to solve differential equations or some kind of differential equations. This method depends on power series, which you studied in calculus 3, I think. Actually, no relation between today's lecture and the previous one about Laplace transform. So in the previous week and yesterday and before yesterday, we learned how to use Laplace transform to solve initial value problems or integral differential equations. And also we use Laplace transform to solve system of differential equations. And as I told you from yesterday lecture and before it, from each one of those lectures, you have one problem in your final. And also from today lecture, you have one problem, at least 10 marks of your final exam. So in today's lecture, we are going to learn how to use power series to find the solution of differential equations. Let me start now. Actually, we are going to cover section 6.1 and 6.2 from your textbook. Actually, the most important thing is 6.2, not 6.1, because the 6.1 is some revision about the power series. Here the objectives, and here a motivating example. Now, can anyone of you remember how we solve this equation? How we can solve this equation? Do you remember?
Using auxiliary
Using the auxiliary, m squared plus 4 equals 0. Then you will find m. Then you will write y equal c1y1 and plus c2y2. Okay, so this is my solution. Let me consider solution of any differential equation. Let us consider the solution of a specific differential equation is given to be y equal e to the x. I remember that if I have an analytic function, so I can write my function as a power series. So now I'm trying to find the solution which can be written as this power series. Notice now the summation from 0 to infinity of some constants times x to the power n. So this is the power series. And in today's lecture, we need to find solution of some differential equation in this form. Now, if I need to expand this summation, so I'm going to use my index to take the numbers from 0 to infinity. So let me plug in first 0. So it is C0x to the 0. Plus, then the second value of my index, it is C1, so x to the power 1, and so on. C2, x to the power 2, C3, x to the power 3, and so on. X to the power 0 is 1. So this is the expansion or the series in the expanding form. Okay, so in today's lecture, we need our solution in this formula. Before we start solving some differential equations, let me do some revision about the power series. I think the power series centered at x equal a is an infinite series or summation in the following form. So the general form for the power series at center a is given by this formula, starting from 0 to infinity n. By the way, this series, it is the same like this. K equals 0 to infinity, ck x minus a to the power k. And it is the same like the series, summation I equals 0 to infinity, ci x minus a to the power I. So this index k or n or I is, I can say, is akhras. It can't speak. Use k, use n, use I, use j, you are free. But the most important thing that here k, that means here k and here k. You can't use here k and here n. No, the same index for all your variables or parameter. Now here the convergence of the power series. Actually, this is like, or the convergence and divergence of the power series isn't important for me. And the radius for the convergence and the ratio and root test, which you studied in the calculus 3, aren't important for me at all. Only to do some revision here. if I have a power series like this, centered at A, I can say that this series is convergence in this interval if there are exist R, the radius of convergence, such that this radius convergence or R can be found using ratio and root test and power series. That means the summation of my series here is convergence is equal to limited number. So when x minus a greater than less than r, sorry, and if x minus a in absolute value greater than r, I can say my series is divergence. Don't worry about those because I don't need them. Now, special case of the power series. So we agreed that our power series is given by this formula. If the coefficients here, the constants, are the derivatives in this formula, I'm going to call this power series, instead of power series, I'm going to call it Taylor series. So Taylor series, it's a power series, but the coefficients here are specific values to be the derivative of my function. Now, any analytic function can be written in this form as a power series. Okay. Also, if the A, this one, if this A is 0, notice now what I need to say. If this A is 0, so specific case of this power series or specific case of Taylor series. If your A is 0, I'm going to call my power series, which has Taylor name now, Maclaurin. So Maclaurin series, it's a power series, and the A is 0 with the coefficients to be similar to those. By the way, if your function is 0, so all of the coefficients here are 0. Did you get the idea what is the difference between Maclaurin and Taylor? Only if the A is 0. And Taylor series, it's a power series with the coefficients to be the differentiation of my function divided by factorial of the order of my differentiation. Now, what I need to explain here, how to differentiate the power series. So I have this power series and I need to find its derivative. Let me, with you, find the first derivative of this summation. Don't forget that the differentiation is linear operator. So if you have summation between two functions or two terms, and you need to differentiate them, only differentiate the first and differentiate the second. So if I need to find the first derivative of my function, which is written in the power series, it's very easy. It will be summation. Cn is a constant, leave it. If you have a bracket to the power n, to differentiate n, you need to multiply by it and subtract 1 from your power and multiply by the differentiation of inside the bracket, which is 1. My n is a start from 0 to infinity. Now I can simplify this differentiation. Notice your n start from 0. If you plug in here n to be 0, so the first term of my series here is 0. So no need to write it because it's 0. So I'm going to start my n from 1, not from 0. Because if you start from 0, so you will write your first term to be 0. No need to write 0 plus some terms. And by the way, if you wrote 0 plus some terms, you didn't do any mistake. But to make my writing simple, so no need to write the first term, which is 0. So here Cn times n, x minus a to the power n minus 1. So you can write in your cheat sheet that the first derivative is given by this formula. Let us check the second derivative. So it is n is constant, Cn constant. I'm going to take the power here, multiply by x minus a to the power n minus 2. And my n starting from 1. Now, if your n start from 1, notice here, it will be 0. So no need to start from 1. Let us start from 2. n minus 1, Cn x to the power x minus a to the power n minus 2. This is the second derivative. So you need to add to your cheat sheet that if my power series given by this, Then its first derivative is given by this formula, and the second derivative is given by this formula. So you need now to add to your cheat sheet the following rules. This is the first derivative, and this is second derivative of any analytic function. Okay? And by the way, if you forget to write them, it's very easy for you to differentiate your power series. Now, before we start using the power series to find the solution, here I wrote the power series when A is 0. So here, not x minus A, only x. Not x minus A, only x. Not x minus A, only x. Okay? Those also, and by the way, this slide is the most important one for me. So I'm going to study and to solve some differential equations around A equals 0, when the A is 0. Okay? Now, operations on power series. What do I mean by the word operations? That means if you have two power series and you need to add them together or subtract between them or multiplication between those two. The most important thing is summation or subtraction between two power series. Here's the rule. Just 1 minute. Give me 1 minute, please. Sorry, give me 1 minute, please. I'm ready. So here, in this slide, I need to explain how to add two power series together. So notice first of all, it is x to the power n and x to the power n, okay? And here, starting from the same value of your index. So I can take x to the power n as a common factor, and the summation, I have only one summation instead of two summations. Actually, in our problems, unfortunately, we have two problems. The first problem, sometimes you will need to add summation n equals 0 to infinity, cn x to the power n minus 1 plus summation from n equals 0 may be dn x to the power n. Unfortunately, at that time, I can't add those two power series together. Why? Because in the first one, I have x to the power n minus 1, and in the second one, I have x to the power n. So I can't take x to the power n as a common factor. Can you hear me?
Yes.
Yes, sir.
So now what should I do to add those two power series together? I'm going to use a new substitution such that so here the first problem, let n minus 1, this index to be one letter k. So because here I have only n, so I need here to only one letter also. From this, you can say that your n, it is k plus 1. That means this power series can be written in this formula, summation, instead of n, you have k plus 1 equals 0. Cn, instead of n, you have k plus 1, I'm sorry, also. X to the power, instead of n minus 1, you have k, plus summation, n equal. By the way, this can be written k. So I can write here k equals 0, dk x to the k. I'm right here. Can I do that? This index is this index can't speak. Okay. Now, great, I have the same x to the power k. I can take it as a common factor. But unfortunately here, notice this one, I'm sorry to write here, that will give me summation k equal negative 1 ck plus 1 x to the k plus summation dk x to the k equal 0 to infinity, both of them. Now, yes, this k is x to the k and this x to the k the same, but here the second problem that your indices isn't start from the same number. So what should I do? I'm going to expand the smallest index to be the same as the greatest index. Now x here, sorry, k negative 1 and here k 0. The smallest one is this. So I'm going to expand this index to be similar to this. So let me write first term when my k is negative 1. So I have c of my k negative 1 plus 1, it's 0. X to the k is negative 1 plus my summation will start from 0 because the first number negative 1, then 0 to infinity of ck plus 1 x to the k plus summation, the second summation, which is dk x to the k. My k also now start from 0. Notice now you have the same x, x to the power k and x to the power k, and the same index. If you have the same x and the same index at that time, you can easily add them together. Leave this term, so c0 x to the negative 1, it is alone, plus the summation, your k start from 0. The coefficients here, ck plus 1 plus dk, and x to the k is a common factor. So I can do that. I can use use the summation between two matrices if I have the same x to the power k and the same index. Okay, and that also can be considered for subtraction between two matrices. Now here in this slide, take a look only 1 minute about those power series. Aren't important for me. I think you studied in the calculus 3 So let us continue now. Here the ordinary points. Definition of ordinary points. I can say that point A is an ordinary point of differential equation in this form if both of px and qx, both of them those are analytic at point A. So you can write this function and this function as a power series. At that time, I'm going to call the point A ordinary point for the given differential equation. And when can I write a function or when can I consider my function to be analytic at point A? If I can write as a power series and the coefficients to be the derivative with respect to x. Also, this slide isn't important. My aim of this lecture is to solve some differential equations using power series. This is first equation and this second equation. Now in details, let us check how to use power series to solve this differential equation. So now focus please. Those steps are very important and you need to follow them in your final exam. So here the solution. First of all, I'm going to write my y as a power series. It's summation from n equals 0 to infinity of Cn x to the power n. And its first derivative from my cheat sheet is given to be summation from n equal 1 to infinity Cn x to the power n. Also, I remember the second derivative of my function as a power series is given from n equal to n times n minus 1 Cn x to the power, here I'm sorry, it is n minus 1 and here it is n minus 2, second derivative. So those rules from my cheat sheet. Now I'm going to plug in those in my differential equation, substitute in your differential equation now here. So I have x plus 2 times the second derivative, which is given to be n minus 1 Cn x to the power n minus 2 from 2 to infinity plus x first derivative is given to be n Cn x to the power n minus 1, my n starting from 1, minus my y, which is given to be summation Cn x to the power n equals 0 to infinity. Okay, now let equal 0, by the way, the right hand side. Now what I'm going to do, only to multiply this x here, distribute the bracket. So I have summation n minus 1 Cn x to the power, now x to the power n minus 2 times x to the power 1, it will be xn minus 1 plus 2 is number, no need to write it inside the summation. Cn x to the power n minus 2. Let me write here my index start from 2 and here my index also start from 2. Plus also here multiply the x inside. So you have summation n Cn x to the power n starting from 1 into infinity minus last summation, nothing to do for the last summation, all equal 0. Now let me check. Can I take x to the power n common factor? No, unfortunately, because I have 2x with power n minus 1 and n minus 2. I'm going to use the blue to solve this problem here. Let me consider my n minus 1 to be k. That will give me my n is k plus 1. So this summation, the first one, can be written as the following. Instead of n, I have k plus 1 equal to. Instead of n, I have k plus 1. Instead of n minus 1, I have k. C, instead of n, I have k plus 1. X to the power, instead of n minus 1, I have k. Great, now I have only one letter as a power for x. Let me use the red now to solve the problem of the second summation. Here, my problem is n minus 2, so let me consider my n minus 2 to be k. That will give me my n to be k plus 2. K plus 2. So this power series can be written, the second one. So here plus 2 power series. Instead of n, I'm going to write k plus 2 equal 2. Instead of n, I'm going to write k plus 2. Instead of n minus 1, n minus 1, it will be what? N minus 1. What do you think? N minus 1 is equal to what?
K plus 1.
K plus 1, great. C, instead of n, you have k plus 2. This is n, okay? X to the power, instead of n minus 2, you choose to be k. Okay, let us continue by using the yellow now. So plus summation. By the way, this index, I can write instead of it k. So k equal 1, k, ck, x to the k. Nothing to do here. By the way, you can leave it as n. You can write it as g, this index, minus summation, k equals 0, ck, x to the k equals 0. Professor, why do you wrote here k instead of n? Only to use one index, not n and k. Now for me, what I'm going to do, only move the number 1 here, so it is summation k equal 1, because I moved the number 1 here. So it is k plus 1, c k plus 1, x to the k. Great. Now notice all of them with only x to the power k. But maybe we have another problem. Now move 2 here to be 0. So it is k plus 1, k plus 2. Am I right here? ck plus 2, x to the k. Great. All of them with power k. So k equal 1, k, ck, x to the k. Excellent. All of them are x to the power k, ck, x to the k equals 0. And last summation with k greater start from 0. Unfortunately, not all my indices start from the same number. So notice now here, let me use the white. This index starts from 1, this from 0, this from 1, this from 0. We agreed that if you have two different values of the beginning of your index, please try to expand the smallest one to be similar to the greatest one. So I'm going to expand here, first term to be 1, and expand here, first term to be also 1. So in the coming slide, let us do that. So I have the first summation with nothing to do. First summation because it starts from 1. So k equal 1 of k plus 1, k plus 1, c of k plus 1, x to the k. Am I right here? Plus, here I'm going to choose the following. Give me 1 minute. So it is here a plus. I'm going to expand 0, please, now. So for this, I'm going to expand 0. So it is 0 plus 1. Let me write here plus 0 plus 1, 0 plus 1, and 0 plus 2. C 0 plus 2, C 0 plus 2, x to the 0, plus the same summation, but now my k will start from 1 because I plug in the 0. So it is k plus 1, k plus 2, ck plus 2, x to the k. Plus, let me check now. Should I expand thing here? No, no need to expand anything because I have the k starting from 1. So I'm going to write, it is a plus, am I right? It is a plus summation of k, ck, x to the k, my k starting from 1. Minus, notice now, you need to expand first term. So C0, x to the 0. C0, x to the 0. Minus your summation is starting from number 1. So it is ck, x to the k, all of them are 0. Now for me, I'm going to take those constants together and the summation together. Notice what I'm going to do now. I'm going to use the yellow to mention those are constant with no x, because it is x to the 0, so it's 1, and this with it is. So here you have 1 times 2 is 2, c2 x0, so it's 1. So I have 2c2 minus the second one, it is only c0, plus. Now here x to the k, x to the k, x to the k, x to the k. And also the same summation, the same summation, the same summation, the same summation. So I can take the summation common factor, k equal 1, and x to the k common factor here. And let me check what do I have here, all of them 0. From the first one, I have k plus 1, ck plus 1. From the second one, I have a plus. I think I missed the 2. I missed the 2. What do you think? Where is this 2? Where is this 2 here? In this line. I missed it. So here you have 2. Am I right? So here you have 2. And here you have 2. So this one, it will be 2 times 2. And here you have 2. Not here. I'm sorry. It is here. I'm sorry also. It isn't here. Nothing here and nothing here. It is here for the second one. 2, k plus 1, k plus 2. Am I right here? ck plus 2. And also here you have k plus ck plus k ck minus ck. Am I right by this writing now? Now for me, what I'm going to do, only to equate between the coefficients of x in the left-hand side and in the right-hand side, nothing here. So for me, the constant in the left-hand side, let me use the blue now, it's better, I think. In the left-hand side, 4c2 minus c0 equals 0. And the coefficients of xk in the left-hand side, those are k plus 1, ck plus 1, plus 2, k plus 1, k plus 2, ck plus 2, plus kck minus ck. All of them, the coefficients of x to the power k in the left-hand side or in the right-hand side is 0. So from this, you can say that C2, it is 1 over 4 C0. I found the fair relation between our coefficients. Now from the last one, this one, and by the way, this is right for the k starting from 1, 2, 3, and so on. I'm sorry for this. Now, what I'm going to do, I can start plugging the value of k. I can start plugging the value of k. So here, if your k is 1, that will give you, help me please, let me call this equation star, in equation star. My k is 1. 1 times 1 plus 1, so it is 1 times 2. C, 1 plus 1, it's 2, plus 2. 1 plus 1, it's 2. 1 plus 2, it is 3. C, 1 plus 2, it is 3. Plus 1, C1 minus C1 equals 0. Let me simplify this. So 2C2, 2 times 2, it's 4, it's 12. 12 C3. C1 minus C1, it's 0 equals 0. So I can say now that C3, it is move 1 over negative 1 over 6, negative 1 over 6 C2. And I know C2 from this. So equal negative 1 over 6, negative 1 over 6, 1 over 4 times C0. This is my C3. This is my C3. Okay, I found C3. Now let me choose my K now to be 2. Professor, how many K do I need to use? At least in your exam, you need 5Ks. If I didn't ask you a specific number, actually, in the exam, I will specify my question. I need maybe 4 terms, 5 terms, 6 terms. And let me explain now what do I mean by terms. Now, my K is 2 in equation number star. So 2 times, so here 2 times the 3, C3. Please help me, plus your K is 2. So it is 2 times the 3. 2 plus 2, it's 4. C of 2 plus 2, it's C4 also, plus my C is 2, so 2C2, minus my K is 2, so it is C2 equals 0. Let me check what should I do now. 6C3, 6C3. Here 2 times the 3, 6 times 4, 24. 24. C4 plus, here C2 minus C2, it is a plus C2 equals 0. Now I'm going to write all of them in terms of C0. That will give me now 6C3. So 6C3. Here you will C3. You will cancel 6 with 6. So it's negative 1 over 4 C0. C0 plus 24 C4. C2 it is C2 it is 1 over 4 C0. So plus 1 over 4 C0 equals 0. Now, negative 1 over 4 and plus 1 over 4, you can cancel them out. So my C4 is 0. Now, let me choose also the K to be 3. K to be 3. In my equation star, focus please. In star, 3 times 4 C4. 3 times 4 C4 plus 2. My C is the 3. So it's 4 times 5. C5 plus my K is 3. 3 C3 minus C3 equals 0. That will give me now 3 times 4. 3 times 4 it is 3 times 4 it is 12. And your C4 is 0. Great. Plus 2 times 4 10 40. So 40 C5. 40 C5. Here you have only 2 C3 plus 2, and your C3 is given to be negative 1 over 6, 1 over 4, C0. All are 0. This cancel. So here I'm going to cancel this 2 with this 4, so it's 12, move it. So 40 C5 equal 1 over 12, 1 over 12 C0. Divide by 40, please. So your C5 now, it is 1 over 12 times 40 C0. I found C5. So if you need to find C6, please your K to be 4. But because I don't have time now, let me stop and let me write my solution in this slide. So now I'm going to write my solution. Notice how to write your solution. Don't forget that your solution is given to be Cnx to the power n, starting from 0 to infinity. Expand it. It is C0 times x to the 0, which is 1, plus C1x plus C2x plus C3x. I'm sorry, C1x, C2x squared, C3x to the power 3, plus C4x to the power 4, plus C5x to the power 5, and so on. Let me plug in the value of my constants. C0, where is C0? No, professor, you didn't find C0. No problem. Let me write C0. Here C0 plus. Where is my C1? Unfortunately, I didn't find C1. No problem. All right, C1 x plus C2. Did we find C2? Yes, it is 1 over 4 C0. So 1 over 4 C0 x squared plus. Did we find C3? Where is C3? Yes, C3 is negative 1 over 6, 1 over 4 C0. Negative 1 over 6, 1 over 4 C0 x to the power 3 plus. Where is C4? C4 is 0. So plus 0 plus C5. What is my C5? It's 1 over 12. 1 over 12 times 40. C0, x to the power 5. And so on. Now, notice this is 0, C0, C0, C0. I'm going to take C0 common factor. So C0 times here 1 plus 1 over 4 x squared minus 1 over 6, 1 over 4 x to the power 3 plus 1 over 12 times 40 x to the power 5 and so on. Don't forget this term plus C1x. I can write it is C0 Y1 plus C2 or C1, sorry, Y2. So Y1, it is all those, and Y2, it's only your X. So I found my solution as a power series. Notice this is a power series. X power 2, x power 3, with those two constants. And notice, because your differential equation of second order, so your solution contains two constants. So, Professor, if I wrote my solution in the exam in 3 constants, no, at that time you did something wrong. Okay? Because at that time, your solution must contain two constants, your differential equation of 2 order. Just 1 minute, please. Give me 1 minute. I'm sorry, but there is a problem with the department. No problem. Yeah. So now let me also solve a second problem, which is initial value problem. Not only differential equation, but it is initial value problem. Don't forget, when you have initial value problem, that mean you need to determine the value of all the constants. Okay? Now let me start. How to solve this differential equation using power series rule. So now here, let us start together. First of all, by my solution.
Doctor,
Yes.
I have a question. So in the last example, we found two terms with two constants, correct?
Yes. Yeah.
Don't I need to find the YP, or is it like
No.
out of the scope?
No. Notice now, because my differential equation here is homogeneous, so no need to find YP. If your equation non-homogeneous, yes, at that time you need to find YP. Actually, in power series chapter, in today's lecture, no YP at all. Only what I need, this final answer here. Or if you have initial conditions, you have to determine those two constants at that time.
Okay, thank you.
Yes. Welcome, Basil. So now let us start solve this problem using the power series. First of all, don't forget that your y from your cheat sheet is cnx to the power n, starting from 0 to infinity, and your y prime is given to be summation n cn x to the power n minus 1, my n starting from 1. Also, y double prime is given to be summation of n minus 1 cn x to the power n minus 2, my n starting from 2. Plug in your differential equation now. So you have x minus 1, y double prime is given by this summation n minus 1 cn x to the power n minus 2, n equal to minus x, y prime is given n equal 1 n cn x to the power n minus 1, plus my y is given to be summation cn x to the power n from 0 to infinity. Now I'm going to distribute as usual here and multiply the x inside. So you have summation n equal to of n minus 1 cn x to the power n minus 1. This is the first one, and for negative 1, so summation n minus 1 cn x to the power n minus 1 starting from 2. No, it must be here negative 2. So first one, x times this, it will be x to the power negative 1. But here, no x, so only 1, so it must be x to the power n negative 2. Minus, now multiply this x, so it will be summation nc n x to the power n without negative 1, starting from 1, plus summation cn x to the power n equal 0, starting from 0. Okay? Now, for me, let me check my x. All of them with power n, unfortunately, no. Some of them is power n minus 1 and the other of power n minus 2. So let me solve this problem by using n minus 1 to be k. That will give me my n to be k plus 1. So this summation, it will be summation. Instead of my n, I'm going to write k plus 1 to be 2. My n here now, my n, this one, it is k plus 1. And n plus 1, n minus 1, it is only k. C of my n, it is k plus 1. X to the power, my n minus 1, it's k. Great, now only one letter. Let me solve the second problem now. My second problem is this one. So I'm going to write my n minus 2 to be k. That will give me my n to be k plus 2. So my summation, second one, the red one now, it will be minus summation. Instead of n, I'm going to write k plus 2. Instead of n minus 1, I'm going to write k plus 1. C of n, k plus 2. X to the power k, great, one letter. My n, it is k plus 2 equal 2. And the rest terms are the same, but I'm going to use maybe the letter k instead of the index n. So k plus k equal 1, k, ck, x to the k, plus summation k equal 0, ck, x to the k equal 0. Now let me move the number 1 here. So summation k equal 1. Am I right here? K equal 1, k plus 1, ck plus 1, x to the k, minus, move this one here also, or it is 2, this one is 2. So it's k, it's 2, this one is 2, okay? So summation k equals 0, k plus 1, k plus 2, ck plus 2, x to the k, minus summation k equal 1, k, ck, x to the k, plus summation k equal 0, ck, x to the k equal 0. Can I add those series together and take x as a common factor? Unfortunately, no. Why? Because I have some summations starting from 1 and the others starting from 0. We agreed we have to expand first term of the smallest index. So let me expand the first term in this summation and in this summation. But also, I'm sorry, I need 1 minute. Give me 1 minute. I'm sorry for this issue. Give me 1 minute, please. I'm ready. So now after finding this form, you can't add those series together because you don't have the same index, or the sum of your indices start from 0 and the second start from number 1. I'm going to expand, as I told you, the series who start from 0. So first one will be the same. So let me here write the first one, which is summation k from 1, summation k equal 1 of k times k plus 1 ck plus 1 k plus 1 ck plus 1 times x to the k. Now let me expand the term. Let me expand the term here for 0. So it is 0 plus 1, 0 plus 2. So negative 0 plus 1, which is 1, times 0 plus 2, which is 2, times C0 plus 2, which is C2, x to the 0, x to the 0, minus the same summation, which is k plus 1, k plus 2, ck plus 2, x to the k, and your k now start from 1, the same. Let me go to the second one. Nothing to do for the third summation. So summation is starting from 1 of kck, kck, x to the k. The last one, I need to expand the first term, so it will be C0, x to the 0, plus summation of ck, x to the k equal 0, starting from 1. All my summations now start from number 1. So I'm going to take the coefficients together, the constant, sorry, those together, and this with them. So I have negative 2c2 x to the 0, which is 1. No need to write it, plus c0 equals 0. Now, this summation 1, this summation 1, this summation 1, this summation 1. So I can take them common factor with the same x to the k. So you can take x to the k, x to the k, x to the k, and the fourth one. So here, let me write the summation here. And by the way, so take the coefficients and let them 0, and here take the constant, sorry, take the coefficients of x to the k to be 0. So you can write k plus 1, ck plus 1, also negative k plus 1, k plus 2, ck plus 2, minus k ck plus ck equals 0. Did you get the idea now? The coefficients of x to the k equal 0 and the constant equal 0. This for k equal 1, 2, 3, and so on. Now from this, you can say that C2, it is half C0. Half C0. To find the value of other constants, let us give our k some numbers. So k equal 1. If the k, let me call this equation star here. Let us plug in. If k is 1, so it will be 1 times 2. 1 times 2. C, my k is 1, so 1 plus 1, it's 2. Minus, my k is 1, so it's 2 times k is 1, 3. C, k is 1, 3, minus 1 times C1 plus C1 equals 0. Cancel out those. So you can say that C3, it is 1 over 3 C2. And your C2, it is half C0. So it is 1 over 3 half C0. So you can say your C3, it is 1 over 6 C0. Let me go to second k. Let me choose my k to be 2. If my k is 2, in star, 2 times 3. 2 times 3. C, my k is 2, C3, minus. K is 2, 3 times 4. 3 times 4. C of 2 plus 2, it's 4. Minus. My k is 2, so it is 2C2 plus C2 equals 0. That will give me, let us try to find this. It is 2 times 3, 6, times C3, which is 1 over 6 C0, so I have only C0, minus 12 C4. Now, negative C2 and plus C2, you have only negative C2, and negative C2, it is negative half C0. So negative half C0 equals 0. Negative half C0, it is half C0. Move this and divide. So your C4, it is 1 over 24 C0. I found C4. Let me continue. K equals 3. That will give me in star. My K is a 3, so 3 times 4. 3 times 4 of C4 minus. My K is a 3, so I have 4 times 5. 4 times 5 of C. My K is a 3, so C5 minus. My K is a 3, 3C3 plus C3. Professor, from where you will find this equation? From star equals 0. Let us together try to do that. Now, 3 times 4 is 12 times C4. Your C4, it's 1 over 24, so you have half C0 minus 20 C5. Here you have negative 2C3. Negative 2C3, and here you have 1 over 6, so it is negative 1 over 3. Negative 1 over 3 C0 equals 0. Let us try to find this. So let me write here. So negative 20 C5 equal, I'm going to move this here. So it is 1 over 3 minus half. 1 over 3 minus half, it is negative 1 over 6. Negative 1 over 6 C5. Negative 1 over 6 C0. So C5, it is 1 over 120 C0. 120 C0. Also, take k equal 4. That will give you an equation star. You will find C6. I'm not going to do that. Okay?
I have a question.
Yes, عبد الرحمن.
The first line خالص اللي هو بالاصفر انا بس
Yeah.
هو term جه منين؟ The last term خالص اللي هو summation of k equals 1 ck x.
Last term. Yeah. Let me go back here. This is the last term. Here it was in 0. Start from 0. I expand for the first value for my index, which is 0. Then I will leave my summation starting from 1. So instead of this, you have those two terms. You have those two terms. One of them is C0x0, and the second one, the same summation, but starting from number 1. Did you get the idea?
يس يا دكتور. يعني هي اخر حته دي يعني the last two parts هي ال it's just one او احنا we expanded it صح؟
Yes.
Okay, yeah, thank you.
دكتور هو احنا we expand and then the other term بتبقى k equals 1 على طول؟
Look, here you have a problem because you start from 0, but this one starts from 1, okay? So you need to start from 1. So how many terms should I expand? Only the term with index 0. But if your index here is 2, this one is 2. So you need to expand the term with index 0 and the term with index 1. Did you get the idea here, Mahmoud?
Yes يا دكتور. بس احنا in the first one اللي هو the first expansion we did the same thing, right?
For this one here? For
Yes.
this summation?
No, the one after here minus the k equals
This
0.
one, you are right. First of all, because I need my index to start from 1, so let me plug in the value 0. So instead of all this summation, I used those two here in this slide. I used those two.
Okay. Okay, thank you, doctor.
Doctor, I have another question بس
Yes,
معلش.
Abdul.
هو if it's equal to 2 يعني if k equal to 2 هيبقى عندي بقى اللي هو two constants one summation صح؟
Yes, you are right. Two constant, or let me say two terms, then one summation. Okay.
Okay, thank you.
We didn't finish. Welcome, Rahman. We didn't finish. We have to write our solution in those constants, and we need to find the constants, by the way, because I give you initial condition. So now my solution, let me go to the yellow. I know that my solution y is given to be c0 plus c1x plus c2x squared plus c3x to the power 3 plus c4x to the power 4 plus c5x to the power 5 and so on. Let us now plug in our constants. So equal, this y equal, y0, c0 I don't know, c1 also I don't know. C2, I think we found C2. Where is our C2? C2, it's half C0, half C0x squared. C3, where is our C3? C3 is 1 over 6, 1 over, so it's 1 over 6, C0x to the power 3. Our C4, where is our C4? It's 1 over 24, 1 over 24, C0x to the power 4. And where is our C5? It's 1 over 20, 1 over 20, C0, x to the power 5, and so on, and so on. Now, you need to notice, first of all, how many constants do you have in your solution in this one? How many constants do you have now? Count them, please. How many constants?
2.
2. Only C0 and C1. Actually, if you don't have initial conditions, stop. You finish the solution. But if you have initial conditions, notice now we have two initial conditions, 0 equal -2 and derivative. So the first one at 0 equal -2. So the first condition, y at 0, let me use the blue maybe, yes, 1 minute. The white. I have the first condition, y at 0 equal -2. This 0 is for x and this for y. So that will give me, instead of this y, I have -2 equal C0 plus C1 times my x is 0 plus C2 times 0 times 0, 0, 0. So I found first constant to be -2. Great. Let me use the second condition. Second condition, y prime of 0 is equal 6. But where is y prime? I should find y prime from this. Yeah, y prime equal 0 plus c1 plus cancel 2 with 2, so it is c0x plus cancel 3 with 6, so it's half c0x squared plus 4 cancel, so it is 1 over 6 c0x to the power 3, and so on. Let me use my condition, this. Instead of y prime, 6. I'm right? It is 6 or yes, 6. Equal c1 plus c0 times 0, because my x is 0, plus 0 plus 0. So my c1, it is 6. I found two solutions. So the solution of my initial value problem is given to be c0, it is -2, plus c1, it is 6x, plus c half, my c0 is -2x squared, plus 1 over 6. My c0 is -2 x to the power 3, plus 1 over 24. c0 is -2 x to the power 4, and so on. Now in the exam, I will ask you maybe find first non-zero, five non-zero terms. So find first 5 non-zero terms. So this one is the first, second, third, fourth, fifth. So no need to write those terms. Maybe I will ask you to write 7 terms. So you need to continue here and to write 2 terms. Did you get the idea now? That how many K should I find? That depends on the problem. If I didn't specify I need 5 terms, so I advise you to use 5 Ks. But if I ask you find only 5 terms or 4 terms, so please don't find more than those, because you will lose your time at that time. Okay? Is it clear? Actually, I finished all the new rules or new ideas of this section or this chapter. So tomorrow, no new rules. But tomorrow, I'm going to solve more problems about today's lecture to let you understand more and to practice. And also, maybe I'm going to solve 2 problems about Laplace transform. So only some revision. And we can meet today at 1 o'clock to do the worksheet together if you have any difficulties.
Doctor,
No.
I have
Yes.
a question.
Yes.
Is it safe to say that there's a relation between the first term, like 1 over 2 c0 x squared? So 1 over 2 and 1 over 6, there's and 1 over 24, there's a relation for
Yes,
me to
you are right.
find
Yeah,
1
but
over 20 without doing
great.
the calculation.
Great, Yusuf, great. You are right.
So I can use
Here,
it?
you are free. You are free. Notice this one can be written 1 over factorial 2. And this one can be written 1 over 3 factorial. And this one can be written 1 over 4 factorial. And this one can be written 1 over 5 factorial. So you can guess this constant to be 1 over 6 factorial. And then 1 over 7 factorial. And then 1 over 8 factorial. But those aren't important for me, because I need you to find the solution of differential equation and not to write it as a specific function. So this one, it is the exponential function. For me, it's enough to find the solution in this formula. But if you can do that, you can write your solution in this formula, that will be great. Excellent, Yusuf. Other questions?
Thank you, Doctor.
Welcome, Hamid. So if you don't have any question, we can meet at 1 o'clock if you need to me to help you to do the worksheet. And bye-bye, all of you. Have a nice day.
Thank you, Doctor. Bye.
Welcome, Islam. Bye-bye. Other questions? Do you have?
Sir, I want to ask you
Yes,
about
ma'am.
the final exam.
Yes, ask me.
if I have actually an internship on Saturday from 9 to 3.
Just
So-
1 minute. Let me stop recording.